first when we graph any function? Can anyone help to tell us what we need to do first when we graph a function? Brilliant. Thank you, Sierra. Good. So here, there is nothing I can do about this. It just says x equals 2. There is nothing I can do. But for this, x not equal to changes into this interval. Parenthesis, union, parenthesis, 2 to infinity. Which means everything but 2. Parenthesis means 2 is not there. Parenthesis means 2 is not there. I start with a little table. I have negative infinity. I have to have 0. I have to have 2. This is a key point or key x value. And infinity, because the domain is all real numbers. I have everything to the left of 2, everything to the right of 2, and I also have 2. Under 2, like we did before, I will write negative 7. But then these parentheses will tell us something else, left and right of 2. So what do I use between negative infinity and 2? It's this. X squared minus 3. What do I use between 2 and infinity? It's this. It's x squared minus 3. How do I know? Between negative infinity and 2, I use this. Between 2 and infinity, also this. So when I plug in 0, I get negative 3. When I plug in 2, 4 minus 3 is 1 inside the parenthesis. Same thing here on this side. 4 minus 3 is still 1. Okay, I know how to graph this. We reviewed this last week. It's x squared. I know how to graph x squared minus 3. Down 3, you already told me last time. So I know how to graph this. But at 2, I have to be very careful, because this will be a full point, and these not. So then I will graph exactly what I have there. 1, 2, 3. It crosses, right, as we know, at the square root of 3. Somewhere here, somewhere here. And at 2 is negative 7. 3, 4, 5, 6, 7. I will present 2, negative 7 with this color. And 2, 1. 2, 1, an open point. 2, 1, 2, 1. So here's the graph. And of course at negative 3. Here, the function has only one point, this one. That's why I put it in a different color. So you see that this piece is the x squared minus 3, but 2, negative 7 is this point. By the vertical line test, this is a function, because here there is only one point. Now, if I'm asked to write the range, careful how we write the range. It is between negative 3 and positive infinity, because I can cross it with horizontal lines everywhere. Union, negative 7. I cannot write this as an interval. It has to be with braces, because it's one point. So this is a little bit more sophisticated type of problem. Let me show you a simple one. So let's say we have f of x equals negative 2x plus 4 for x less than or equal to 1, and x plus 1 for x greater than 1. This is a much easier problem to understand and to visualize. So let's also look at this. I know this interval is negative infinity to 1, no question. I know this interval is 1 to infinity, no question there. Can anyone, other than Sierra, because she already answered, but of course I'm not preventing Sierra from answering, give us the domain of this function?
Would it be negative infinity to 1 and 1 to infinity?
But if I have everything, why would I break it at 1?
It would be negative infinity to positive infinity.
That's it. Because there is no problem. 1 is here, and 1 is not here, and it starts at the same point. Good. So a nice problem with domain or real numbers. I like that. And now I get my table started. Is that clear, everyone? Any questions so far, please? Any questions? Okay. So then I get my table going. Of course, I have to have negative infinity. I have to have 0. 1 is on this side, infinity. In ascending order, I have to have the domain from negative infinity to infinity. 0 must be in the table, always. And this is a key point. It has to be in the table. Right underneath it, I will have a bracket that is touching the parenthesis. And you can say, but wait a minute. Here they were not touching because I had a different point in between. But here they are touching. Okay. Then I make myself a note. Between negative infinity and 1, I have to use negative 2x plus 4. Between 1 and infinity, obviously, I have to use x plus 1. Now, I plug in 0, I get 4. I plug in 1, negative 2 plus 4 is 2, inside the bracket. I plug in 1, I get 2. I wanted to change that. I didn't want them to start at the same point and end at the same point. I want you to see the jump. So 2 plus 1 is 3. And I'm going to use 2. 2 times 2 is 4, plus 1 is 5. I need 2 points on this side because it's linear. I need 2 points on this side because it's linear. Yes, you would have said, I'm sure, don't plug in 1 in here because you have the parenthesis. You can't plug in 1 here. True. But if I don't plug in 1, then I have to plug in 0.1.0000001. I don't want to do that. I will plug in 1 and leave it open. So this will be a full point because of the bracket, and this will be an open point because of the parenthesis. That's what I want you to see. This particular jump, it's called. Okay. So then 0, 4, 0 for x, 4 for y, 1, 2 with a full point. Notice that I used green. I'm done with green. You don't have to do that. The point I'm making is you cannot extend this graph. This graph exists only between negative infinity and 1. Now between 1 and infinity, I have a different graph. When x is 1, I get 3. So open point at 3. And 2 is 5. You cannot extend the blue to the left. You cannot extend the green to the right. By the vertical line test, this is a function. If I'm asked to find the range, can anyone give us the range?
Is it 1 point positive infinity?
So the positive infinity is good, but where does it start?
Ew.
Yes, remember? Thank you, Brianna. So 2. So it starts at 2 with the bracket. Excellent. Thank you. Do we feel better about piecewise defined functions now?
Yes.
So please watch those videos. Good. Other questions for me? Do we need to go back to finding domain, or can we move on? I think we finished that.
Just when we're taking exams,
Yes.
we have to submit work that shows us doing it exactly this way, like within the table.
If you have a different method that works and you're not getting confused with the full point and the open point, I'm fine. You don't have to use my table. I'm not forcing anyone to use this particular table. But there is, I've been teaching for 27 years. I have yet to see a better method than this. I know the book shows 2 different tables, but you don't know where to stop. You don't, this is your x, this is your y, this is your x, this is your y, this is for one function, this is for the other. But how do you present this? I don't know without this table and without this explanation. And if you graph something like this is incorrect. And this method will not tell you where to stop and where to start. This, in my opinion, I accept it if it's correct and if you present it correctly, but it's a waste of time because you're going to leave a gap between these two, because these two will not help you determine this jump. This is a waste of time. Try to watch the videos. I have 10 other problems in previous semesters' videos. Watch this. It's extremely simple if you understand it, of course. If you use this, you're going to leave a jump, and I can give credit for that. So please, try to understand this method. I will never say that my method is the best, but for this in general. But for this, I have yet to see a better method. If you have it, use it. Does that answer your question? Is that okay?
Yes, thank you.
Thank you. Good. So I'd like to continue with R.4. So we are reviewing the slope and linear functions and so on and so forth. We discussed all this before. We talked about linear functions with a slope that is positive. We talked about linear functions with a slope that is negative. We talked about horizontal lines with a slope equals 0. And we talked about vertical lines with a slope does not exist. We like to say undefined. Fancy word. Well, what it means is DNE. It does not exist. Okay. Then we looked at y2 minus y1 already over x2 minus x1, which is the slope. Now what I would like to refresh your memory on is y equals mx plus b. Anyone remembers? It's okay if you say I don't. Anyone remembers what this represents?
Slope-intercept.
Slope-intercept form. Very good. Awesome. Who was that? Levi? Thank you. Good. And of course, this is a point called 0, comma b. This is the y-intercept, 0, comma b. And also we have one that is, I didn't mean to write that. I meant to write this. Y minus y1 equals the slope times x minus x1. Anyone would like to tell us what this is?
Point slope.
Thank you very much. Nathan, thank you. Point slope form. When do I use this? I use it when I have 5, comma 3 as the point, or points. I may have another. But when do I use this? When I have 0, comma 3, for example. I use this. If I have another point or points not 0, comma a number, I will use the point slope form. But if I have 0, comma a number, I will use this. It's so much easier. Okay, good. So I'm going to share my screen, and I would like to go to, this is on page, where is it? Page 44. I can go to 44 if I manage to find my keyboard. Okay, good. Good. So let's see what kind of problems we want to work on here. You choose anything you want. I love it when my students choose. It's so much easier for me. So we are given 2 points. We're asked to find the equation of a line. Find the equation of a line given slope and another point. So you choose. Let's see what else is here. I'll come back. I want to show you, and we always, this is an application type of course. It better not be. So I'd like to talk about profit and loss analysis, something like this, after we choose another problem before this one, just a numerical situation, and then I'd like to go to look at a word problem so we can continue. So what would you like to choose?